Hi guys. I found a new feature of this app which allows me to put my headshot in, which is wonderful. Hopefully, I'm making this a little bit more interactive, but I kind of have the eerie feeling that I'll regret this feature very, very soon. Um, Anyways, we're gonna cover the quadratic formula today. I'm gonna go through this really quickly in this unit because quadratic formula is a lot of tedious calculation. There's not much logic behind it once you understand where it comes from. So, quadratic formula is the formula we use to solve, or can be used to solve, every single quadratic equation, except that in general, it's the last resort we want to go to because it's so much calculation and so tedious. All the other methods, whether it's vector form, factored form, complete the squares, are all fairly straightforward, and there are many less steps, so it reduces the chance of you making calculation mistakes. Nonetheless, quadratic formula is very important. And so, first of all, what is quadratic formula? It's right here, as stated in this screen here. For any quadratic equation, the solution to the x is x equals negative b plus minus square root of b squared minus 4ac over 2a. It's just a simple memorization of this. There's not much logic to it. There's one important concept here. It's called the determinant, which is b squared minus 4ac. We're going to discuss this more in detail later because this part of the quadratic formula, the determinant, determines how many solutions the quadratic equation has. So for now, pause the video for the more advanced kids if you want to give it a try and see if you can prove that this indeed is the solution of ax squared plus bc plus bx plus c equals 0. So try to solve it yourself. Here we're asked to solve this equation 3x squared minus 4x minus 9 equals 9. We're going to use quadratic formula. I always start with writing the formula out because it's so many variables moving around, and I identify the ABCs. I begin to substitute them inside the quadratic formula, and then the rest of it, you just keep simplifying them until the end that you cannot simplify anymore. And from that point forward, you draw the conclusion that this equation has two real solutions. One is 2 plus root 31 over 3. One is 2 minus root 31 over 3. That's it. Okay? Again, as you can see, lots of calculations. As long as you know the formula, it's all substitution and then simplifying. How can you determine the number and types of roots for a quadratic equation? So it can have real roots or imaginary roots. And here are three scenarios with three quadratic equations. It's asking you to graph them, then use the quadratic formula to find the roots. So you can do that, but to answer the question above, pay attention to the x-intercept here, right? Well, I actually shouldn't graph the last one. So the first graph has two roots. The second one has one. The third one has none. And so that's interesting. What determines that? Use your quadratic formula to prove that indeed there are two real roots in the first one in the second one, and none in the third. And then see what you find. And from here, I have to erase the points. Sorry about that. From here, you can see that we use quadratic formula, calculated these roots, and they reflect what I was graphing on top, right? And in the first, again, In the first scenario, I have 2. In the second scenario, I have 1 solution. And then in the third scenario, I don't have any real solutions. I have 2 imaginary or complex solutions, complex roots. So the question is, what determines it? And pay attention to here. Remember at the start of the lesson, I mentioned that this is called determinant. If the determinant is greater than 0, I would have 2 roots, which is the first scenario. If it's 0 by itself, oops, if I move, it's gonna move my highlighters too. If it's 0, I have 2 identical real roots, meaning I have really just 1. And then if it's less than 0, in the third case, I have only complex number roots. Okay, so the determinant, again, D equals B squared minus 4AC has to fall into one of the 3 categories. If it's greater than 0, I have 2 roots. If it equal to 0, then I have 1 root. And if it's less than 0, I have no real roots. So that's the importance of the determinant. Here is a interesting example to see how we use the determinant. Rachel is about to serve and toss a tennis ball straight up in the air. The height h of the ball in meters at a time t in seconds is given by h of t equals negative 5t squared plus 5t plus 2. Will the ball reach a height of 4 meters? So height, h equals 4, then we can write the equation as negative 5t squared plus 5t plus 2 equals 4, right? And then we can simplify it to rewrite it into negative 5t squared plus 5t minus 2 equals 0, with a being negative 5, b being 5, and c is negative 2. Now, in order to know if the ball will reach the height of 4, which is really another way to ask, does this equation have real number solutions, or is it imaginary? If it's imaginary, it doesn't exist in the real world, right? That's another way to think about it. So all we need to look at is the discriminant. So calculate the discriminant, b squared minus 4ac. We arrive at negative 15, less than 0. So this equation has no real solution. Now, we can also use the discriminant to find a particular equation to force the equation to meet our demands. What does that mean? Here's a equation, 2x squared plus bx plus 18. We don't know what b is, and the f of x is 0. And we're also told that there's only one real solution right here, which is a giveaway to say the discriminant is 0, right? So with that, we return to the original equation, find out a is 2, c is 18. I plug it into b squared minus 4ac equals 0 because when I force the discriminant to become 0, that's when I have only one solution, one real solution. So the answer came out to be b equals plus minus 12. So there are 2 possible equations here. 2x squared plus 12x plus 18 equals 0, and 2x squared minus 12x plus 18 equals 0. Now, one thing I would like to add is that at this level, I will not take this as a final answer because it's not completely simplified. What I would do is I will take these 2 as my final answer. That's something our textbook did not do well. Okay? And just do a quick check of the study tip. it says that note that this equation will have two real solutions if b is greater than 12 or b is less than negative 12. It will have two non-real solutions if b is between negative 12 and 12. So that's actually a really good reminder. We didn't really talk about it. Take a minute to think about it, why that is the case. So to summarize, this is what we learned in this unit. Quadratic formula is x equals negative b plus minus square root of b squared minus 4ac over 2a. It sounds like gibberish, but you need to make sure this formula is in your blood because it will come in very handy as you move along the math curriculum. Now, the most important thing in that is the discriminant because it offers you insights about how many real solutions the quadratic equation has. As illustrated below, when the discriminant is greater than 0, it has two real solutions. When it equals 0, which is my favorite, it has only one real solution. Sometimes we also call it we have two identical real solutions. And lastly, when it's less than 0, it gives us the imaginary number and it puts us into the complex number arena. So we like that one much less, right? So that's it for this unit. I will see you guys soon.